So we've reached our last two examples, and I'm going to try to get both of these done in the same video here. So for the first one, we're asked to integrate from 2 to infinity dv over the square root of v minus 1. I'm going to use the direct comparison test for this one. So on the interval from 2 to infinity, you'll notice that the square root of v minus 1 is going to be a positive number. And also, for values of v greater than or equal to 2, v is going to be greater than or equal to the square root of v minus 1. Okay? So for v values greater than or equal to 2, v is greater than or equal to the square root of v minus 1. Because this is true, we can say that 1 over v is going to be less than or equal to 1 over the square root of v minus 1. So I'm going to use the direct comparison test, and we're going to look at 1 over v compared to 1 over the square root of v minus 1. So what I would have is that the limit as b goes to infinity of the integral from 2 to b of dv over v is going to be less than or equal to the limit as b goes to infinity, the integral from 2 to b, dv over the square root of v minus 1. Now, you remember back to the very first example I did, when you've got 1 over your variable, in this case v, it converges when the exponent on the variable is less than 1, but it diverges when that exponent is 1 or greater. Well, here I've got 1 over v to the first, so this on the left here is going to diverge. Since the function that I'm looking at is greater than or equal to this, mine will also diverge. And that's kind of the other side of the direct comparison test, okay? If you can find a function that is smaller than yours and that function diverges, then so will your function. And then the last one here, and it's actually going to make use of that first example as well. This one we're asked to integrate from 4 to infinity 2 dx over x to the 3/2 minus 1. That's a little bit of a mouthful. This one I'm going to use the limit comparison test, and I'm going to compare it to 1 over x to the 3/2. So I'm going to compare with 1 over x to the 3/2 using my limit comparison test. Now, a couple things to keep in mind here. When I compare with the limit comparison test, it's not going to give me a value for the integral. It's just going to tell me if my integral is going to converge or diverge. Going back to that first example again, I've got 1 over x to a power. Since that power is greater than 1, in this case 3/2 is greater than 1, I know that this converges, okay? So this converges. When I use the limit comparison test to compare this with what I have here, if I get a number, then that tells me that my function also converges. It doesn't say what it converges to, but just that my function converges. So I'm going to look at the limit as x approaches infinity And in this case, you can put either function on top. I'm going to do the 1 over x to the 3 halves on top. So we have 1 over x to the 3 halves over 2 over x to the 3 halves minus 1. I'm going to rewrite this because right now it looks like a mess. So we have the limit as x approaches infinity of 1 over x to the 3 halves times x to the 3 halves minus 1 over 2. So if you multiply this out, and I will do that, you can end up with two separate fractions. You can have x to the 3 halves over 2x to the 3 halves minus 1 over 2x to the 3 halves. The first fraction, the x to the 3 halves, are going to cancel out. So I've got the limit as x approaches infinity of 1/2 minus 1 over 2x to the 3 halves. Now, as x goes to infinity, the x to the 3 halves is going to go to infinity, and 1 over infinity becomes a 0. So this limit is going to be 1/2 minus 0, or just 1/2. Now again, what does this tell me? It doesn't say that my integral equals 1/2, but the limit comparison test says that because when I took the limit, I got this to equal a real number, because what I was comparing it with, the 1 over x to the 3 halves, because that converges, so does my function, okay? So we can say that the integral from 4 to infinity of 2 dx over x to the 3 halves minus 1 converges.